Hello everyone, welcome to second module for Dynamic System Practicum. Here I will guide you in English. This second module is about programming under Matlab environment. This module objective is to understand if condition, and then for looping, and then an introduction of Simulink, and also a communication between Matlab to Simulink. Now let us see the exercise 1. Okay. We are given a quadratic equation here, and we want to find the roots of it. Because the roots of the quadratic equation can be distincted by its determinant, so we can implement the if condition to define which condition is matched with our roots. So how to implement the if condition? First, you must memorize this command. There is a basic command that is used in if condition. The mandatory command is if, else, and end. While this else if is if we have more than two conditions. So if there is more than two conditions, we use else if. So how this if condition is work? Let's say when we execute this command determinant, and then we get this determinant is below 0, so this command is executed while this command is not used. Okay, or if the determinant is more than 0, so only this command is executed while this command and this command is not executed. Okay, so let's do it in the Matlab program. Before we do the exercise in the Matlab program, you can read the syntax of if in the help documentation. So this is the syntax. There is if, and then the expression you choose, which is like determinant is below 0, and this is the statement that you want to execute. And then else if, this is determinant more than 0, and then followed by the statement. And then else is something that is outside of these two statements, and then it is the next statement. Now let's go to the Matlab program. So let's say we define A is 0, B is 3, and C is 6, maybe, yeah. And then we get the determinant is equal to B square minus 4 multiplied by A and C. Okay. So we get the determinant is minus 39, and then if we can apply the if condition. If determinant is below 0, don't forget to shift enter, and then we use the statement. This is A, and then else determinant more than 0, this is B. And then else is this is C. And then we forget to end it. Okay, then we can enter. So if we know that the result of the determinant is minus 339, so this is below 0. So the answer must be this expression. Okay, let's enter. Okay, so you can see that if the condition is met with this, you can define this as, you can see that this is the command that is execute. Let's try another value of A. If we want to use this C1, and then maybe this is not 1 but 4, and this is not 2 but 1 also, or 2, okay. And then the determinant, and also if you want to use this all, select all, and then enter. So this means that the determinant is more than 0. So the program will execute this command. Okay. You can try another ABC somehow that it will be determinant equal to 0. So this command that will be executed. Let's go back to the next question. So the question is, complete the above command to obtain the value of roots in example x1 and x2. Okay. To find the root of the equation, you can use help. So you type it as root. Okay, this is the Matlab function to find the root. So you can use this functionality, and then don't forget to make your equation into a matrix P. So for example, if there is a polynomial equation, so you need to write the matrix into like this. So this is 3 and 2 and minus 2, and then you get the root. Okay, let's try. Okay, so we need to make a P matrix, yeah. This P, according to the quadratic equation that we define, so P will become A, B, and C, okay. And then you can find the root. Let's say the root is x, and then you will find root P, and then you can display it. Okay, so this is the roots of P, which has two roots, that is because this is B, this is B, B is the two distinct real roots. So this is the two distinct real roots. Okay, if you want to show in x1, so you can just pick x1, okay, and then x2, like you have learned before. Okay, now the answer of the first question is done. And then you can write down the general structure of if program. Okay, now next is exercise 2. Before I continuing, I want you to understand that this what if I use the P become A, B, 0, and C. So you need to understand what the difference between this P is A, B, C, and if you write A, B, 0, C. So find the difference, okay? Okay, let's continue. Let's first understanding what the comment is. So clear all, close all, you know this is. And then we want to check if the matrix of A is rectangular. So we want to check it. To do that, you must define the tools to check the size of the matrix. Therefore, you define the A matrix, and then you define the size of A. So this is the new tools that introduced to you, which is size A. I will show you what is size A. Okay, we have P, so we want to define D is size P. Okay, so if you define D as size P, it will display this is 1 row and 4 column. Or you can define matrix A and B, no, not A and B, maybe M N is equal to size P. Okay, so this means that M is row, N is column. If you not define as the matrix, it will only display D is equal to 1 and 4. According to this size A, now you can define the if condition. So, what the condition is, if BA is not equal to KA, it is not rectangular. And then if BA also not equal with KA, so it is not rectangular. Only when it is equal, BA equal KA, it will recognize as rectangular matrix. Okay, you can exercise it by yourself and then check if the program works properly or not. Okay, let's next to exercise 3. Before continuing exercise 3, I will show you another toolbar called Descript in the Matlab. This is the place that you can store your comment and modifying it easily. Okay, let's say clear all CLC. You want to 1, 2, 3, 4, 5, 6, 7, 8, 9. You want to execute it, you can use Control Enter. It means that you execute all the program that right in here, and then or you can use only the separate program, separate comment. You can use this evaluate selection, or you can choose all evaluate selection. It is the same, and then you can save it in one or any name you want to write it. Okay. So what exercise 3 is talking about? So it is said as modifying metric element, and in here we will introduce you how to use for looping. Inside the for looping is if condition. Okay. Here the metric element are modified to be 0 when the value is below 3, and modified to be 1 if it is more than 3. So first you need to define metric A, and then here the tools that we will introduce you as length of A. Length of A means the length of the metric A, so it is 9. So you want to define n as a length of A, okay? And then this is used to define the for looping. So actually what is n for? N is to define how many loops we want to do in our program. In this case is we want to loop it until 9. So we want to modify 1 into 0, 2 into 0, 3 into 1, okay, and 4 until 9 into 1. So therefore we need 9 loops, okay. After we define how many loop that is needed to modify each column or each element in metric A, now we define the if conditions. So the condition is 2, which is below 3 and more than 3. So this is the first condition, below 3, and this is, you can say that else is more than 3, okay. So if it is below 3, so we change the A matrix of 1 into 0. This is for 1, and then after that for 2, and then after that for 3 until 9. Okay. Okay, let me try it. First is we define the length of A. Okay, if you want to execute it for check, it's okay. N is equal to length of A. And then this N is equal to 9. Okay, and then you define for E equal to 1 to N. And then don't forget to include the N statement. After that, we use if condition, which is A E equal to, not equal to, but below 3. And then A E become 0. Else if AE is more else, else, and then AE become 1. Then we can execute it using Control Enter. Column at least n missing. Oh, n missing. Okay, this is must be n also. N also. Okay, and then Control Enter. Now, what is it? Okay, because I don't give a semicolon, this is will show you how the execution work. First is the first column, and then second column, and then third column become 1, and then fourth, and then 5, and then in the end is all become 0 and 1. Okay. If you don't want to display this, you can use semicolon, and only display the last one, and you call A here, A. Okay, now only A that is displayed. Okay, let's go back to the module. So I hope you understand what the if condition and for looping here. Now that you can write down the general structure, you can see in help, you can type for looping and it will be displayed the structure, and you can write down here. Now we will do the exercise 4, which is modifying matrix element. I think this is the same, so you don't have to do it. This is the same. So okay, and then you can continue to exercise 5. Now what is it? This is the multiplication of matrix A and matrix B. Okay. Okay, in this exercise, you want to check whether the A matrix and B matrix can be multiplied. So based on the matrix multiplication, that the inner size of matrix A and matrix B is the same. It is the condition, first condition. So define the size. You need to define the size of A and then the size of B, and then the condition is applied there, which is the inner matrix, which is Ka, and BB must be equal, so it can be performed. If Ka and BB is not equal, so the multiplication cannot be performed. I think you have understand this, so you can do it by yourself. And then maybe this is need to be explained more. Okay, what's the means of this program? Actually, this is a loop inside the loop. So Matlab will execute the inside loop first. Let's say E is defined as 1, and then only J that is changed until it is N. After that, the E become 2, and then J is changed until it is N. Like that until E is N. Okay, So I hope that you understand the basic idea of loop inside the loop. Now, what is the meaning of this both that both syntax? So you define x as a. This is you have understand this, which is all the column in I row, and this is all the row in j column. So you will have x and y, and then you input the x multiplied by y into the D matrix. So the end of this program is D matrix. I hope you understand. If you don't understand, you can check this one by one by manually define the J and I. Okay, next we want to do the exercise 6. Okay, this exercise is called as recursive process. So this is a process of reconstructing the new signal from the first signal, from a continuous signal. So this is the first signal, and then we want to reconstructing it into the new signal. What the difference between the first signal and the second signal is the sampling rate, lower sampling rate. Okay, so it is called as resembling a discrete signal. Now what we will do, first we define the first signal, which is x1, and then we first define t, which is 0, and this is the sampling period 0.0001 until 10, and then we can execute this into matrix T and matrix x.1. Next, we define the length of x1. So we define the length of this, and then we define also the k, which is equal to 1 until 200 until n. Where does this 200 is come from? This is from this definition, which is x2 are taken from two data points of x1 t separated by another 199 data point in between. So now we can define x2, this is x2, as x1 which only peak in 1, 200, 400, 600, 800, and so on. So it means that the x2 will be resembling of x1. I hope you understand this. This is the important part in this equation or in this problem. Let me repeat it. So you can click the matrix of K in the workspace and see what is inside, and then you can understand what is the mean of this inside the bracket. And also the t is the underscore 2 because if we want to plot this graph, it must be has the same size. Okay, so now we have both two signal, which is x1 and x2. Next one is we make a figure 1, which is plot of t and x1. So this is the first signal, and t2 and x2. So this is the second signal. This is the legend. Okay, and figure 2. What is the difference between figure 1 and figure 2? Oh, only this. So it only show how to mark the graph. I hope you understand the explanation. You can learn, you can pay attention on this. Okay. And then after that, what is the step size of x2? Step size means sampling period. So the first signal has the sampling period 0.0001 second or 0.1 millisecond. Now the question is sampling period for x2. Okay, you can check in the x2. This is, if we see this metric, you can see that this is 0 and then 0.0001. So you can check the sampling period in T2. Okay. Okay, now modify the program with the data point capture is 700. So you change this 700, and what is the new step size? So you can check the new t sampling period. Okay, what will happen if the sampling rate is too low? You can answer this by evaluating the x2 with 200 sampling and x2 with 700 sampling. You can compare it, and then you can answer in here. Please don't say the reverse because this is sampling rate. It's not the sampling period. Okay, now let's go to exercise 7. Now we learn about numerical derivative of discrete signal. This exercise is about derivative but using numeric. So to do so, first we want to define an analytical derivation first. Okay, this is, you must define the t. You can input this by fixed number to0, and then step size is 0.001, and then t final you can say 2 or 3, and then x is the discrete signal. So this is sine 2 pi multiplied by 1 and t, and then this is derived and become, we call as y ideal. So this become 2 pi 1 multiplied by cos 2 pi 1t. Okay, so this is, let's say this is the analytical derivation. Now we want to compare it with numerical derivation. So what should we do when we want to do the numerical derivation? You have known that the definition of derivation is delta x divided by delta t. So this is the numerical derivation, the first numerical derivation. And then this is the delta x. So this is if we choose I as 1, so this is x2 minus x1. So this is the delta x, while t is the delta t. Okay, so this is actually delta x divided by delta t. Now the question is how to write the delta x divided by delta t in Matlab. First is you must define the n as length of x. Okay, so this is the reference length of x. After that, you define the temporary matrix. This is zeros. Zeros is a matrix with 0, with the size is 1 and minus 1. Let's say example. I will give you example. A equal to zeros 2.1. Okay, so this will give a matrix with row is 2 and column is 1. If we say here zeros 1 until n minus 1, let's say we try it. A equal to zeros 1 until maybe 10. It means that the matrix will be 1 row and 10 column. Okay, 1 row and 10 column. Okay, so the first one is you define the length, and now you define the zero matrix. This is called as zero temporary matrix because we will fill it with this comment. The next question is why this must be n minus 1. The answer is the derivation needs 2 points to make 1 point. Okay, so let's see, this is as delta x. It needs 0.2 minus 0.1 to make 0.1. Okay, so the last number will not form any other point alone. Okay, now the comment for make a numerical derivation will be like this. First, we must define how many loops we need to fill the zeros. Okay, so it must be the same here and here. And then we define the y numerical. This is I, and then this is the delta x that is take from this signal, and then we get the y number complete. After that, we must define the t because the t number is different with the initial t, so it must be take from t from 1 until n minus 1. Okay, and then we can plot the figure by using subplot. This is the ideal and this is the numerical. So you can do it by yourself and see how the time period will affect the plot. Okay, so and then you can answer this question: how do we make the numerical derivative getting close to analytical one? To answer that, you must modify this and then analyze it. Now the last exercise is about a brief introduction to Simulink. So please open your Simulink. If you don't know how to open it, it must be like this. This is Simulink. So you can start by click it. The page will be so like this. You can click the blank model. This is the blank Simulink. And now you can open, this is the library. This is the library. And then you can use commonly used block. Okay, now let's see. This is the Matlab program. You must make it first. Let's say we don't use a strip, we use a comment window. Okay, we need to make T matrix and then X matrix, and then define signal as time series X, T. Okay, let's we do that. T equal to 0, 0.001 until 5 maybe. I don't want to be 10. And then X equal to sine 2 pi multiplied by T. Okay, we have matrix X and T, and then let's say signal equal to time series of X, T. Okay, so this is the, in the workspace, you will see this is in double time series. You can click to see it. So this is data that has been bundled by Matlab to communicate the Matlab to Simulink. Okay, you don't have to understand what is inside. So you just use this name of variable to communicate with Simulink. Now what next? Okay, now because this is introduction, we only use signal and scope. So we check the Simulink from this library. From this library, you can choose source, and then from workspace, you can put this and name the data with the data that we have created signal, and then we display it in the scene. which is scope, and then we connect it. Now we just run it. After you run it, then you can click the scope to see the result. This is the result. Let's say we have defined t from 0 until 5, and we don't define t from 5 to 10, but here is the 5 until 10 is displayed, so you must change this into 5, and then run again. Okay, now the display will be like this. We have a sinus signal, so it must be a smooth size. To make it smooth, please open the model configuration parameters, and then you need to change the variable step into fixed step, and then change this step, this step, fixed size step, into 0.001. Okay, and then apply. Okay, and then run it again. Now the figure is smooth, and this is look like how the sine wave it should be. To copy this figure, you just click file and then copy to clipboard and paste in your worksheet. Let's go back to the module. So after that, you plot in your exercise. Now we will continue to the next signal, which is we want to do this equation and how to solve it. So how to write this equation into a Matlab? Okay, so this is yt is equal to 2xt plus 1. Let's say we have xt as a signal. We have defined it, and then multiply by 2. So xt must be multiplied by 2 and plus 1. So we must put 1 to add it in here. So, and then this is the sum. So we must put the block, and then we sum it, and then we can use to workspace into Matlab again. This is the execution will be in Matlab. Okay, let's retry. We go back to the Simulink, and then we need to make operation. This is, you can use again. Gain is a multiplication, and then you change this into 2. Okay, and drag the row, and then you must use this sum here, and then drag this, and then you need a constant. Just look for constant. Where is the constant? This is the constant, so you can put here, and then connect it. Okay, and then we can display it again in sync in the scope. Okay, then you can execute. Oh, sorry, this is not the scope, but to workspace. To workspace, this is from. Where is the workspace? We can see in the sync, and this is to workspace. Sign out. You can name it as signal 2. Okay, and then you execute it. After finish, you can go back to the Matlab, and then you have find that there is the signal 2 that execute from Simulink, and then you can plot signal 2. Now the figure is like this, and then you can use edit and copy figure to copy this figure to your worksheet. Okay, this is the last page for module 2. I hope that you can understand what I've explained. Although in English, I hope that you fully understand it. Thank you.